Okay, this is a demonstration of the Illuminations, NCTM's Illuminations Power of a Point app. Now down on the right hand side I've got my little notes here so that I can kind of keep track of what I want to say. Okay, this is NCTM. It does not need a membership, and so your students can log in and try this out. You do need these activities to show up. If you log into an activity and it doesn't show the activity right here, then it says there's a problem with your Flash, your Shockwave, your Java. Don't try it. I've used up a lot of time trying to fix it for Windows 7 and 10, and if it don't show up, it probably means you won't be able to get it to work, and it may just be inactive, because here I just fired this one up. It works fine, even though I did a lot of messing around with everything else. Okay, here the point of this is to show that a couple different ideas. When two chords intersect each other inside a circle, the products of their segments are equal, and also when the product of total length and external segments are equal. Product of the total length and the external segments are equal of the chords. So I'll show you these two examples. First, intro to the tool. Here you can drag around your circle. Click on your F, drags the whole thing. Okay, it's not dragging. Okay, we're having a little problem here again. But that should drag the circle around without changing it, and it's taking a little bit to react. Must be because of the recording slowing down the computer. Change the radius of the circle with G over here. Drag it right, left. Okay, then to move P around, the point in the center, you can drag the P. Also, you can drag the points on the circle, so if you just want to drag these around. Now, one little glitch: if you get P on top of the center of the circle, it will get confused. If you try to drag P, it will drag the whole circle, so you need to move something and get P off the center so that you can then drag the circle around if you want. Now, the obvious giveaway here is that you show segment lengths and show products. So here's all your lengths. As you move this around, you'll see that they change. Like I said, this is hesitating now. It must be because of the recording is taking up some memory here. Also, it'll show the products. Now this is the dead giveaway. The products of the two pieces of your chords, if you multiply this length times that length, it equals this length times that length. So these will always be equal, and that's the point of this applet. You'll see as the lengths change, their product stays the same of the two pieces. So that demonstrates that. Now there's another little glitch, as in up at the top here it says on the outside of the circle, and I had a heck of a time dragging this P outside the circle until I finally figured out how you do that. You don't drag the P. What you do is you move the chord until the P goes outside the circle. So drag the chord around until the P goes outside the circle, and that's what I have set up here. And you'll see that this is outside the circle, and that the product of P to C times C to D is the same as the product of P to B times P to A. So we show those lengths and show those products, and you'll see that those are correct also. So mathematical fidelity, and I would say cognitive fidelity, because this is how you would look at it as a student, that these things are being multiplied, and you could check these with a side calculator if you wanted to see that they work. Okay, now another idea that's not directly shown but was shown on the bottom of this website over here. We can get some movement right here. This young man shows that this length here squared is the same as this length times the entire length. So I went ahead and set that up right here. This is not directly shown on the software, so I set up a tab here with the software, the applet power of a point, to show that this is true. What I did was I drug C and D as close as I could to each other so that it would be virtually a tangent line, and you see CP and DP are practically 6 centimeters, and that is, if you square that, you'll get this AP times PB, BP. So if you take this length times this length, you get about 36. And if you take 6 squared, you get about 36. That was as close. And that would be kind of an extension, because that's not directly easy to see on this software. Okay? So that's another extension that could kind of push the students a little bit to see that and get that set up, but that would be a tangent line. The length here squared is equal to this length times this entire length. Okay? If you want to change radius, you see as you drag the radius, it stays the same, and back and forth. So that messed up my nice neat 6's there, but you get the idea. Hide products. Now, another idea is that you could, well, if that's how you move P around, is to bend the chords so it stays outside. If you want to move it back inside, you have to push the chord all the way around so the P goes inside the circle. And that was the one little thing that I figured out, even though you can drag P sometimes to move it. In order to get it in and out of the circle, you have to rearrange the chords. Okay. This is kind of a servant software for a teacher. I mean, you're pretty much just relying on the software and the kids to see that you click it and it shows you what it shows you. I'm thinking the only way to really probe their knowledge would be to have them do a recording just like I'm doing now and explain to me what I am explaining to you. So I'm not so sure, other than through recording, how do you probe their knowledge. Maybe have them write it up and do a couple examples. So mathematically correct, cognitively correct, pedagogically give or take, because it's not really pushing and forcing them to see any patterns. You would really be stretched to get the students to see the third one I'm showing you here, and you absolutely cannot get them to see, let me show you what I mean. Another idea is that, okay, let's drag this around. Whoops, too much. Drag this up, get the P to reappear. This angle here is equal to the 1/2 the difference of the lengths of the chords, the positive difference. If you took this chord's length, subtracted it from this chord's length, and took 1/2 of that, you'd get the angle measure of this angle P. That's not shown here at all because there's no angle measure. But you could demonstrate or talk to them about that. So pedagogically, I think it just demonstrates, it seems to me to be a total servant. That's my thoughts. So that's all I got. Is there anything else I need to talk about? Nope, that's it. Thank you.